here with Kiana and Jessica, physics superstars, and we're doing the crane lab. So they've put this meter stick here, and we're gonna hang a mass here somewhere. And then as we move it up, eventually the friction force against the wall will be too small and it will fall. So I'm gonna show you the calculation of how we do that lab. You can take it down again. Thank you. Okay, so I am playing, right? Okay, so everybody just pause for a sec if you would. I'm making a video of how you can do your calculations. So you're gonna start with the hinge on this side. So I'll call it hinge 1. And we look at all the torques. Now your mass, you're gonna move your mass closer to the wall until it falls off. And wherever that distance is, let's say you made a little loop of string and you had your mass hanging in there, and it should have been 200 grams. And so your force of gravity of the mass, I'll call it FGM, is here. And then the force of gravity of the ruler will be in the middle, whatever that mass was. I'll call it FGR for the force of gravity on the ruler. The torques here and here have to be equal. And I'm going to call this the friction force, because that's the only thing holding up over here. So these torques all have to be equal. So we'll say torque counterclockwise has to equal torque. Torque clockwise equals torque counterclockwise. So this is just 1 meter times the force of friction, because it's all the way from the hinge. And then the other torques are going to be 0.5. So this is going to be 0.5 here. 0.5 meters, and that's going to be 0.5 times the FG of the ruler, whatever you get that to be. And then you have to add this, and I'm going to call this D1. So that's D1 times FG of the mass. And these two you can find just by weighing them. That should give you the force of friction. So that's part 1. And then you go back over and you make the hinge on the other side. So we'll say this is hinge 2. And maybe I'll use a different color if I can find it. So here, same thing. These torques now have to equal those torques. So you've just moved the hinge, but still the torques around those hinges have to be the same. So you'll say torque clockwise has to equal torque counterclockwise. So your torques clockwise will be the same, except this now is going to be, I'll call it D2, it'll just be 1 minus D1. So it's going to be D2 times FG of the mass plus 0.5 times FG on the ruler. And now that's going to be equal to this. Now over here, you have some forces. You have a tension force in the string, which we can componentize into FTY and FTX. Now FTX and the normal force here will be the same. The normal force is pushing out from the wall because it has to be perpendicular. And so this has to be equal to that. So if you can find this, then you know your normal force. If we measured this and this, you can find your theta. That's the same as this theta. So really we just need this, and we know the angle. We can use trig to find the FTX. So how do we find that? Well, that's going to be this torque right here. And that's going to be 1 meter times FTY. So add this all up, divided by 1, it's going to be the same thing, that's FTY. And once we get that, well, tangent of theta is equal to FTY over FTX. So we can find FTX and put stuff tangent down. And once you know FTX, that's the same as the normal force. And then the very last thing you do, so this is part 2. And once you know the normal force, then the very last thing you do is you say the friction force over the normal force is equal to the coefficient of friction, which is our goal. And if you do all that, you should be good.